In today's experiment, we will be tackling Gay-Lussac's law. Joseph Louis Gay-Lussac was a French chemist and physicist who was well known for his daring ascents in hydrogen-filled balloons. While studying the different expansion properties of gas using water vapor, he discovered that equal volumes of all gases expand equally with the same increase in temperature. He published his research in 1802 to what we now know as Gay-Lussac's law, which states that when quantity and volume are kept constant, the pressure and temperature of an ideal gas are directly proportional. This means that when pressure increases, then temperature will also increase and vice versa. This relationship can be defined through this formula, which states that initial pressure divided by initial temperature is equal to final pressure divided by final temperature. This law can be observed in our day-to-day life. Did you know that the pressure cooker is an example of this concept? As the temperature of the water inside increases, water vapor is produced, yet the pressure cooker is designed to not let air escape. This means that volume remains constant. Over time, the high temperature combined with the high pressure are tenderizing even the toughest meats. In today's lesson, we will be testing out this gas law using items you can easily find around the house, so stay tuned. Are you guys ready for today's experiment? First, let's prepare our materials. We will be needing a candle, a lighter, a glass cup or jar, a cup or two of water, food coloring or a powdered juice drink, preferably a dark color, and a shallow dish. This experiment could potentially get a little messy, so you will need to wear your lab safety gear. If you have all your materials ready, let's proceed to conducting the experiment. Step 1. Add 1 to 3 drops of food coloring to your water and mix well. If you're using a powdered juice drink, add only a spoonful of the powder to the water. Step 2. Carefully pour your mixture into the dish. Make sure you have about an inch or 2 of water. Step 3. Place your candle in the center of the dish. Step 4. Light the candle and watch the magic happen. Here's a question. What did we observe throughout the experiment? Before we lit the candle, the water level throughout the dish and inside the jar was even. While the candle was lit, the water inside the jar slowly started to rise and the flame started to grow weaker. After the candle was fully extinguished, we can see the water level inside the jar was noticeably higher than its surroundings. So how do we explain what happened in the experiment? Was it magic? No, this was Gay-Lussac's law. When he put the glass jar over the lit candle, the flame started to heat up the gas particles inside. As the gas inside increases in temperature, the particles are now excited. Because they contain more energy, they move a lot more and much faster, so they try to spread further apart. But since the sides of the glass jar cannot expand like a balloon, they push harder and collide more frequently with the walls of the glass jar and the water at its base, therefore increasing pressure. As we know, fire uses oxygen for combustion. After a while, most of the oxygen particles have been converted into CO2. This hot carbon dioxide air goes upward, pushing the remaining oxygen down. This is what caused the candle to grow weaker and weaker. Once the candle is fully put out, the air inside begins to cool down. As the temperature decreases, the gas particles lose their excitement and they move at a much slower rate. Because they're moving less, they stop spreading away from each other and they push less frequently against the walls and the water. Since the particles collide less frequently with the walls of the container, therefore pressure decreases. But why does the water rise? Since the gas particles are pushing less and colliding less frequently against the water and the glass, there is now a difference in pressure since the air inside the jar has a lower pressure than the air outside. As a result, the gas particles pull on the container walls and the water below to achieve equal pressure. Since the walls of the jar are rigid, it is much easier for the air to pull the water beneath, which is why the water rises. The water will continue to rise until the gas particles have reached equal pressure with the outside air. This is just one of the many experiments that test Gay-Lussac's law. These findings could be vital in discovering new applications for the law in the fields of science and in the real world, so check out our other experiments. Also, if you want to learn about Boyle's law and Charles' law, they can also be found on the site. Thank you and keep exploring.